Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning. So today we proceed with chapter 6b, known as gravimetric analysis. So as you can see, this is a continuity with a 6a um, for gravimetric analysis. So here is the step involved in gravimetric analysis. As I said before, okay, there's about combination. Now I just separate it into a very proper way, which is you can understand more. Which is the first one is preparation of the sample, second one is precipitation, third is digestion, fourth is filtration, washing, followed by drying and ignition, and then perform the weighing and calculation. So maybe some of the step here will combine, for example, filtration and washing, and then weighing and calculation. So it will be 6 steps only, but here I just want to separate it into a very proper sequence so you can understand more. Okay, so as I said, this is a precipitation process. So precipitation reaction refer to the process or the formation of an insoluble salt solid form when two solutions containing soluble salt are combined. So the insoluble salt that falls out of the solution known as a precipitate, where the precipitate must be slightly soluble substance or insoluble ionic solid with a known composition. So we need to know the composition of the precipitate that produce. Alright, so the precipitation properties, as I said, precipitation required the precipitating reagent or agent in order to measure the precipitate that you can get from the reaction um, more reliable. Okay, for precipitate, there is a characteristic of precipitate that we need to have. First one is readily filtered and purified. The second one is the precipitate must be low in solubility, which is it can prevent the losses of the analyte during filtration and washing. And it must be stable or unreactive with a constituent of atmosphere. And the last one is that you need to know the chemical composition of the precipitate after ignition or drying process. Then this is the formation of precipitate. As I said, there's a few types of saturation process. So which is we have the saturated solution, unsaturated solution, and supersaturated solution. So in order to get the precipitate, you need to have the analyte react with precipitating agent, which is precipitating agent will help to make sure the precipitation process successful. Okay, then what happened there, the second step is supersaturation, and then barulah boleh berlakunya precipitation. So as you can see, bila kita sebut saturation tu, saturated tu meaning that tepu lah, tapi kita nak dapatkan precipitate lebih kena tepu. So sometimes we need to apply the heat in the reaction, or sometimes kalau dalam lab kita guna pakai water bath. Water bath tu kita boleh control dia punya temperature. Okay, so here is the precipitating agent that I said, which is substance that affect the formation of suspension in solution that reacts specifically or selectively with the analyte to form a precipitate. Precipitating agent is causative substance that affect the formation of suspension in solutions, or the one that causes the formation of the precipitates. Alright, there is two types of precipitating reagent, which is organic and inorganic precipitants. So this is the characteristic of precipitant or precipitating reagent, which is readily dissolved in the solution medium. And then the second part is very selective, only produce the desired precipitate. Precipitant should be specific. It should give a precipitate with one particular ion. And then a number of organic reagents yield precipitate with metal ion which are coarse and bulky and therefore easy to handle for gravimetric works. So organic precipitant have high molecular weight and yield a relatively large amount of the precipitate with a small amount of the metal ion. So this is a very important part lah, which is precipitant or precipitating agent ni akan play important role in order to get the process to get the desired precipitate that you want. So as I said, this is a table. You can see from this table, you can print out from this handout. Okay, so there's an example of precipitating reagent. Okay, and then with the cation react with the precipitating reagent in order to make sure the precipitation reaction will occur. Right, for example, from this example table, you can see that lead to iron Pb2+ lah atau plumbum 2+ akan react, dia boleh react antara dengan dilute HCl, potassium iodide Ki ataupun potassium tetraoxochromate 6 solution. So you can see that antara tiga ni there is a 3, jangan masuk tiga-tiga pula, tiga-tiga tu tak boleh lah. So you need to choose one. This one is in order to make sure you will have the plumbum yang you nak sebagai you punya precipitate. Alright, so which is will react with a dilute HCl, so there is a chemical reaction, chemical equation there. Pb2+ plus 2 HCl produce PbCl2. So HCl will dilute HCl, the chlorine from dilute HCl will react with plumbum, will be selective plumbum, and then to produce white precipitate known as a plumbum chloride. Then if let's say react with potassium iodide Ki, it will produce a yellow precipitate plumbum iodide. So there is a two difference, will give a different color of precipitate because you punya precipitating reagent is different. Okay, so same goes, you can see there for calcium, for zinc, aluminium, copper, iron 2+, and also iron 3+. So you will use maybe a same or different types of precipitating reagent. Okay, so this one is precipitation reaction of some anion. If let's say you want to have the chloride ion as you punya product kan, so you need to use silver trioxonitrate. So silver nitrate in order to make sure you will have the white precipitate of silver chloride. So for lead, try PbNO3 2+ also can be a precipitating reagent in order to make sure you will have the chloride ion. So it will give you a white precipitate of lead chloride or plumbum chloride lah. Okay, you can go through to the second example of an anion, third and fourth anion. So which is sulfate, sulfate ion, sulfide ion, and also carbonate ion. Okay, this also table from table 8.1. I already list down here the selected precipitation gravimetric method for inorganic cation and anion. So you can use the precipitant. So precipitant itulah react and then precipitate form. Okay, so maybe some of the precipitate form will give a same chemical formula after precipitate weak, because sometimes no need to have the drying process, you will have the same product. But sometimes after you dry the product by using ignition, so the product will give you a different precipitate for waking. Alright, so now we proceed with the type of precipitate that produce. So the desired precipitate, we need to have the crystalline precipitate, which is a very small number of large particle. So the large size of this crystalline precipitate is above than 10⁻⁴ centimeter. And then for your information, for crystalline, normally the reaction involves very spontaneously. That's easily to filter and also purify that precipitate. So at the same time, you need to have a granular precipitate is very desirable in gravimetric analysis because it presents a relatively small surface area and is thus less liable to contamination, as well as being easier to filter than a gelatinous precipitate. So gelatinous precipitate ni biasa kita deal with the precipitate yang colloidal. Okay, macam main susu tu kita biar lama sikit kan, dia macam gelatin sikit kan, itu is quite hard actually. Biasanya dia ada contamination. Okay, the precipitation form should have low solubility in the solution. That one is the characteristic of a precipitate. That is a favorite question. Okay, so you can see from this picture, so this is a crystalline precipitate, but in lab punya study so if let's say you want bila you buat degree nanti mungkin lah ibu dapat benda ni crystalline precipitate you akan nampak. Tapi the process is tedious juga bukan mudah juga, so you need to kawal everything, the temperature, the environment, and make sure bersih, keadaan tempat tu adalah bersih dan sebagainya. Okay, and then the second types of precipitate is known as a colloidal suspension. So bila kita tengok sikit, colloidal ni biasanya air susu lah. Air susu tu dia adalah colloidal. So very tiny particles, powdery, and have a diameter from 10 power negative 7 to 10 power negative 4 with will not settle and not easily filtered, because bila you tuang dia readily dissolve dalam the new solution, so it's quite hard actually to filter the colloidal suspension precipitate. So because it will the particle will be suspended everywhere in the solution, so you need to take a long hour maybe in order to make sure to have the filtered colloidal suspension precipitate. Okay, so here as you can see, this is the size of particle. Okay, the size of the particle here. So this is a formula to have the particle size. Is it you want to measure the particle size? You can use this formula RSS, relative supersaturation, minus equal to Q minus S over S. So where Q is a solute at any instant, meanwhile S is solid at equilibrium. Normally question asks you about the how about if let's say the RSS value is very high, what happened to you punya precipitate? So if high or large number or amount of RSS, so it's a very concentrated solution, and then nucleation process win. So nanti kita akan tengok nucleation process tu apa. And then the product or the precipitate that produced is in colloidal suspension precipitate. If let's say you have a very low RSS, okay, you have a low RSS, so meaning that in dilute solution the particle growth win. So particle growth tu maksudnya dia akan dapat large size of precipitate. Okay, so the normally your precipitate form is a crystalline state. What does it mean by nucleation? The process forming a nucleus. So sekarang ni nucleus tu yang melebihi lah, maksudnya kalau untuk jadi colloidal tu nucleus tu yang dia yang akan grow kan. Okay, the initial process that occur in the formation of crystal from a solution. So depends both of the crystalline or colloidal suspension, both of them need to have the nucleation punya proses. Tapi dekat dalam case untuk colloidal suspension precipitate, so nucleation yang win. So which is berlaku nukleus, membentukkan nukleus saja. Dia tak buat pun particle growth. So bila ada nukleus, suddenly particle growth dia akan lagi cantik dan dia akan menghasilkan very close packed with a position in space relatively to each other and produce the crystalline solid, the desirable of your precipitate. Okay, you can read this lah. Okay, so this is the mechanism of precipitation, which is first you need to have the nucleation. Okay, which is sometimes it berlaku spontaneous tu particle growth, normally kita akan hasilkan the product is crystalline precipitate. Meanwhile, if let's say we need to have the kita inducekan dia, meaning that dia akan produce ada contamination kat situ, which is kita introduce the seed particle to get things started, for example dust, another crystal, glass fragment, and so on, in order to make sure barulah dia berlaku ni particle growth tersebut. So ada dua method lah mechanism of precipitation. And then okay, wait. Alright, so as you can see here, This is in order to produce the precipitate, which is for your crystalline precipitate, which is nucleation berlaku, and then this spontaneous terus particle growth. Dia berlaku, dia nampak dia dah bentuk, terus dia akan grow sampai besar, sampai dah dapat larger size of particle, which is 10 power of -4 centimeter, in order to make sure you will have the crystalline precipitate. Okay, this is a mechanism also for precipitation. Okay, once a nucleation site has formed, other ion are attracted to the site. So bila lah macam bila you are the center of attraction, so all people yang akan dengar, oh you bagus, boleh terangkan yang bagus, so semua orang akan datang berkerumun. So dia berlakunya growth kat situ. Ni influence macam influencer lah, macam you tengok kat IG ramai kan sekarang ni, influencer beli barang, beli apa semua tu kan. So from there, an example, the particle will grow, satu benda yang benefit, so datang, orang akan datang, and then dia akan grow. Very simple. Okay, so this is a nucleation site. Rapid cooling causes many nucleation site, while slow cooling yield a few crystals. So meaning that rapid cooling tu is not good lah, because it will produce the colloidal suspension. Meanwhile, for slow cooling yield a few crystal tu akan hasilkan crystalline precipitate. So suhu tu penting. Okay, ways to favor the formation of larger particle of precipitate. So this is there is a six points that you need to know, which is precipitate from dilute solution, add precipitating reagent slowly and stir effectively, which is you tak boleh throw-kan semua. Kalau katakan 15 ml you nak add the precipitating reagent, tak boleh terus tuang 15 ml tu, it's not good. So what you should do, you need to just add little by little amount of the precipitating reagent. As I said, lowering the temperature slowly is good. Precipitate at low pH and precipitate from the hot solution. Hot solution tu bukanlah yang panas betul So untuk this is the chemical kan, chemical mungkin dia punya panas tu adalah 45 darjah, something like that saja. Okay, this is the things as I mentioned. This is just summarize of what I'm already tell you previously. So you can see from this chart. Okay, so as I said, once again, I want to highlight these properties of good precipitate. It must be low solubility to avoid loss during washing, consists of larger crystal size, so it can easily filter and washes free from impurities, stable, and mass non-chemical composition.